Welcome class to the guidance video on the worksheet called Pyramids and Cones. Pyramids and Cones. The essential question on this worksheet is, how do I find the volume of pyramids and cones? That seems rather self-explanatory. So you have so far covered prisms, which deal with rectangular and triangular prisms. You have dealt with cylinders, and now we're going to add to that the volume formulas for pyramids and cones. Let's go through your guidance. The first section, how do you find the perimeter, the area, and the volume of these three shapes? I sure hope you are proficient in being able to do these three things. So that'll be your review. The next section, this is similar to your last worksheet or two worksheets ago. Here you've got the three different shapes, a pyramid, a cone, and a sphere. All of this information, please fill it out exactly the same way you filled out in your flip book. So write down the name of the shape. What is the name of the shape's base? What is the formula for the area of the base, and then how do you figure out the volume of that particular shape? You will see the biggest thing here different is for a pyramid and a cone. If you look at a pyramid, it looks kind of like a rectangular prism, except for instead of having opposite faces that are congruent, all of the lateral faces, the side faces, end up connecting together at a particular point. We've called this point the apex when you look at your video notes. A cone also has an apex or a top. You've got a circular base, and then all of your lateral face is just basically wrapped around the circumference of the circle, and it meets together at a point at the top called the apex. And then the sphere is the real, back to these two, and then you'll notice your volume formula changes. Instead of being base area times height, it is 1/3 of the base area times height, and that makes at least some sense because this is much less than a cylinder. You can see if a cylinder is base area times height, a cone is going to be less than that, because as we go up the height of this cone, we don't remain the same shape all the way through each cross section of this. We actually get smaller as we go toward the apex. So mathematically it actually turns out it's precisely 1/3 of the volume of the comparable cylinder. So we've got a circular base, and then 1/3 of that base area times the height. The sphere is the oddball, very different from the rest of them. You'll notice in your notes there is no base shape, and the volume formula is right out of your flipbook notes. So fill that table out to get credit for that as I grade these. The next two things, class, I want to cover is two definitions. Actually, I should have this written down as 3 definitions, but I kind of dumped one in the middle of the others. The first thing I want you to notice here is a regular polygon. When we use this word regular polygon, it means all of the side lengths are congruent. So for instance, a cube is a regular polygon. All of the side lengths are congruent. So if you look at this, what is a regular prism? A regular prism is a prism with a base which is a regular polygon. So in this case, not all the faces of a prism need to be regular or congruent sides, but the bases do. So I could actually draw something here. If I drew two shapes here and I connected these two, I'm going to do real quick and connect them together. If this base and this base are squares, they are regular polygons, and that means that this could be called a regular prism. Let me get rid of that drawing, it's so terrible. Alright, so what's a regular pyramid? Well, a regular pyramid is a pyramid that has a base which is a regular polygon, just like a regular prism. So if you look at your pyramid, if the base of this pyramid has all sides congruent. In this case, that makes us a square. This would be called a regular pyramid. You could also have a base that was an equilateral triangle. All three sides of the triangle are congruent. All the lateral faces go up to the apex. That would be a regular pyramid. In fact, you could have any shape as the base. It could be a hexagon as long as all six sides of the base were congruent. So if the base polygon is regular, then is considered a regular pyramid. Now the reason I'm covering this with you is because you're going to notice on your worksheets and on the test, if it says the shape you are figuring the volume for is regular, you need to know that I only have to give you one side length of that base. You should know that every other side length is congruent. All right, let's do one problem together here on the front. Let me fix this. I keep having to fix this. Sorry about this, class. My width is not allowing me to show you the whole column. There we go. All right, so find the volume of each of the solids shown below. On each diagram, shade the base and circle the heights. Let's do question number 1. Let me see if I can get my colors here. So it's easy to find the base of a pyramid and a cone because there's only one. You don't have to make a choice. The base is the one face of the shape that doesn't touch the apex. So if that's our apex right there, the only face that doesn't touch the apex is the base, or the bottom, in this case, of the pyramid. But it doesn't need to be on the bottom. This pyramid could be upside down. Just realize the base is the only face that doesn't touch the apex point. All right, and then the height is very easy to figure out. The height is the one dimension that's not part of the base dimensions. In this case, the height, see how that arrow points to that line right up in the middle? That line is an inside of the pyramid, and it goes from the apex down to the base. And I wanted to show you, class, that height measurement will always be perpendicular to the base. So in this case, you can see a little right triangle, or sorry, a little right angle mark right there. All right, let's figure out the base. Well, this base is a rectangle, so I know the base is going to be length times width, and that's going to be 15 times 12. And you can figure out what that base is. And remember, the unit of measure for area is centimeters squared. What is the height? Pretty easy, 22 centimeters. And then the volume, now be careful on this because a lot of students on the test will forget, wait a second, this is not a rectangular prism, this is a pyramid. That means the volume is 1/3 of the base area times the height. Now I'm going to save you guys a little bit of time and help you not make a mistake on this. When you put this formula in your calculator, when you plug in the base area and the height, make sure you do it like this. I'm going to bring up the calculator and show you. I've modeled this for you before so you understand how to do this. Hold on a second while I try to figure out how to get my calculator to move. I cannot get it moving with my... Oh, there we go. All right, so class, when you put that formula into your calculator, put the 1/3 in parentheses, 1 divided by 3, that's what 1/3 means. And now you can put your formula in just like you normally would. So whatever the base area is, let's say it was 15. I'm not telling you it's 15, let's just suppose it's 15, and then let's say your height was 6. So there's 1/3 times the base area times the height, and you press equal, you will get the volume. So always put this in parentheses. In fact, if you just want to do this for yourself, to remind yourself, always in parentheses, so it treats that 1/3 as a separate term. And then you should be able to easily find your volume, and that's going to be in, when you get done, that'll be in centimeters cubed. Alright, so there's your help on finding the area, or sorry, the volume of a pyramid. This one, take a look at this. It says the base shape of the pyramid below is a square. That means this is a regular pyramid. And so if you know this side length, you better know what this side length is. And so if you know it's a square, you know what this side length is, and you can find the area of a square again is length times width. Remember, shade the base, circle the height. Your height goes here. Find your volume. Again, don't forget, it is a pyramid. That means it is 1/3 of the base area times the height. And I have to confess to you, I was so lazy sometimes in math in high school that I would just say, well, I know how to do this now, so I would quit writing the formulas down. I'm going to ask you, don't create that habit for yourself. The habit you should create is when you show your work in math, you should always write the formula down and then plug in the things you know. Okay, and when I say always, it means you never skip that step. It is a terrific habit in math. It lets your teacher or whoever is grading your work know that you understand what the formula is. And I'm going to tell you, if you write this formula down, you will almost never forget the 1/3 in the front. The students who forget the 1/3 are the students that go, okay, volume is equal to, and they'll put their base height 23 times 7. And since they didn't write their formula down, they will easily forget to put that 1/3 in there. So make yourself write your formulas before you plug in your variables. It should be a habit you always have in math. All right, let's go to number 3. Don't need to cover this with you. Pretty simple. You've got a base, that's a circle. You know the area of a circle is pi r squared, so you should be able to figure out the base area. Sometimes students will ask me, should I leave my answer in terms of pi right here? Like if you know the radius is 6, should you do this class and write 36 pi centimeters squared and not put this in your calculator and estimate it? And I would tell you that is a great habit to get into. You should try never to resolve or convert pi to a number until the very last moment if possible. Otherwise you're rounding and then you're going to round again. So I would leave this as 36 pi centimeters squared. Your height is going to be 5 centimeters. Don't forget to shade your base and circle and label your height. Now your volume is going to be 1/3 of base area times height. And that means we're going to put it in our calculator like this. 1/3. My base area is 36 pi. And that doesn't look very clear. Let me fix that. 36 pi. And my height is 5. Now you can round your answer to 1 decimal place. And again, don't forget centimeters cubed here. So I would say don't put this in your calculator. Leave it in terms of pi. Put it down here in terms of pi. And then put this whole thing in your calculator at one shot and you'll get a much more accurate answer. All right, let's continue. Careful on number 4, class. I'm not giving you the radius. I'm giving you the diameter. Make sure you convert that to the value of the radius before you find the volume of that cone. Let's continue. We learned in your flip book that if I draw a pyramid or a cone and I make it oblique, we talked about this word oblique, and that means instead of this apex being right in the center of my base, it's kind of off to the side. The good news is it makes no difference. If you know the height and you can figure out the area of the base, the volume of this oblique pyramid is still 1/3 times base area times height. And the same thing here. It makes no difference. Kind of cool how you can move that apex anywhere you want. It could be way over here or directly in the center of the circle. The volume calculation is not affected as long as you know the height. Now I want you to be careful. This is not the height. This is called a slant height, and you do not use that in your final volume calculation. You must know the height, which is going to be perpendicular to the base. So the height is always perpendicular to the base. Here you notice it's marked for you. It's perpendicular to the base. This length right here has nothing to do with the volume. That is not the height, that's the slant height, just like I talk about in your video notes. All right. Well, now we get a little more complicated here. Question number 7. They don't give you the height on this one. They give you the side lengths of the base, which is a square, 18 feet and 18 feet, and they give you a slant height of 15 feet. Sorry, did I say 15? If I did for the base, that's 18 and 18. They give you a slant height, and remember, we're learning here, you can't use slant height to figure out the volume. You're going to have to figure out what the actual height is, and we want to know, what is this dash line right here? What is the height? Come to the rescue, Pythagorean theorem. So pretty easy to do. Class, since we know it's a regular pyramid, we know that this apex is exactly on top here, and we've got a base area, or a base that's a regular polygon. So that means we can use Pythagorean theorem. In fact, if you look at this diagram, there's a right triangle that I sketched right inside of the pyramid. If you can figure out what the height is, this leg of the right triangle, then you know the height and you can figure out the volume. In class, I'll just give you a little tip here. I took this triangle and I pulled it out. If that's a right triangle, and we know the slant height, which is the hypotenuse, is 15 feet, take a look at the base. If we look at the base, if the base is an 18 by 18 square, can you imagine, class? If this is 18 feet, how long is this leg right here? And if you guessed it is half of 18, you are correct. So this would be 18 divided by 2, which is 9. I'm going to ask you to use Pythagorean theorem to figure out the missing leg. And please be aware, class, the hypotenuse goes here in C. This 9 can be one of the legs. You're going to have to figure out what the value of B is. And once you know the value of B, then you'll know your height. And once you know your height, you'll be able to figure out the base area, the height, and then volume as 1/3 of base area times height. So this is why, one of the reasons why we learn Pythagorean theorem and right triangle geometry is here it shows up in the need to understand this to be able to figure out the height of this pyramid. All right, let's go to the next one. Number 8. I actually underlined this to let you know this base is an isosceles right triangle. I just want to verify this so you guys know this. An isosceles right triangle means that the two legs are congruent. So if you look at this base area, which is right here, there's my right angle, this is my hypotenuse, and if I know that this leg is 12 centimeters, then you should be able to tell me what this leg is equal to. So that's what I want to cover with you, that you should be able to figure out what that other leg is. That means you can easily find the area of this triangle. Remember, it is 1/2 of length times width, so you should be able to figure out that base area and then figure out your height, which is given to you, and then find your volume, 1/3 of base area times height. All right, hope that's helpful to help you be successful. Number 9, you should be able to handle this on your own. You got to figure out, what did this guy Jimmy do wrong in figuring out his volume, and what can you do to correct it? All right, last question, number 10. You've accomplished, hopefully many of you remember, you've accomplished problems like this before. In this case, we're not being told for this cone, so we're going to circle this, let's diagram a cone here. Teach you guys how to draw a cone. It's pretty easy. Draw an oval, put a dot right in the middle, pick another dot that's directly above that, connect that together, and then there's your height, and then you can go ahead and draw your, visually what appears to be your edges of your lateral face. So there is your cone. And the question is, it's not giving you the radius and giving you the height. It's giving you the height, so we're good with that. My height is 8 inches. But I don't know what the radius is. My radius is a question mark. But it does give us the volume. So class, remember, why am I teaching you to always write your formulas? Because if you write your formula, you'll be able to solve for other missing values. In this case, we don't need to solve for the volume. We already know that. We've got to solve for the radius. Now look at our hint. Find the area of the base first and then find r. So here's how we're going to use our formulas to save the day. The volume of a cone is 1/3 base area times height. Now look at this formula. How many variables do we know? We know volume, so I can plug that in. I'm going to put this 1/3 in parentheses. We do not know base area because we don't know the radius, but we do know the height. Now class, look, there is your basic algebra from last year. You should all be able to solve this equation and find out what capital B stands for. Now I'm going to give you all a tip to help you with this fraction, because we know a lot of you do not like to deal with fractions, so I will tell you, then get rid of the fraction. And the way you do that is you multiply this side, instead of by 1/3, which is your fraction, you multiply it by 3/1. If you multiply this side by 3/1, look what happens, class. 1/3 times 3/1, 1 times 3 is 3, 3 times 3 is 3. That becomes 1, and you can remove it because it doesn't affect your answer anymore when you multiply by 1. But that means you have to multiply this side by 3 as well. Now I'm just going to write it as 3 because 3 is the same as 3/1. Now look what happens. Now I'm going to multiply 134 by 3. And now I'm going to end up, let me change colors here. Actually, I'm going to let you do this. 134 times 3, get your number right there. That's going to be equal to, and I'm going to rearrange this. This is 8 times capital B. Then divide both sides by 8, and you just found what the area of the base is. And once you know the area of the base, well, that becomes pretty easy, class, because you know another formula. The base area of a cone is pi r squared. So you're going to take this value of your base area, plug it in right here, and then look, if you plug it in right there, you have another equation with only one variable, r. Divide both sides by pi, and then you will square root both sides, and you should be able to find your radius. So I'll let you go to that. If you struggle with that and cannot get the answer that's in the answer key, text me back and remind and say, Mr. Z, I am struggling with question number 10, and I'll be happy to give you guidance. All right, last thing is complete the square. This should be right in your quadratic equations flip book. Remember, with completing the square, if we're going to, in this case, we're not solving it, we're converting to vertex form. All right, so in this case, you don't have to tell me what values of x will make this equation equal to 0. You have to change this from standard form, which is what you see right here. You need to change that to vertex form, which is what you see here. And complete the square does this for you. In fact, for my students from last semester, you have a page in your flipbook, Quadratic Equations, where I go through those steps. For those of you who were taught it a different way, here's another way to look at this. Go ahead and change this y value to 0. Oops, not 2x. So here's another way to think about this. You can just say, well, I know I could just get rid of my y value. I'll put it back in here later. So get rid of the y value. So I'm going to say that's going to be equal to 0. So 0 equals x squared minus 6x plus 3. And then go through all your steps for completing the square. We're going to move the 3 to the other side. That's going to be negative 3. equals x squared minus 6x. Remember now you're going to make a blank space on both sides because you want to create a c value that makes a perfect square quadratic. And remember, we're going to find this blank space by doing b over 2 squared. Your b value here is -6, so divide that by 2 and then square it. You're going to get this number that goes in the blank. And then remember, you're going to add these two terms together. You're going to factor these three terms. And remember, it's easy to factor. We can factor this right side by using the term b over 2, or -6 divided by 2. You're going to find out you're going to factor using this number. Class, when you get all that done, all you do is move all the terms to one side and put the f of x back in your final answer. So don't worry about changing that to 0. When you get done, move everything back to one side and then put your 0 back to f of x. And that will convert this from standard form to vertex form. Again, any questions on that or issues, send me a text and remind. Let me know. I'll either create a little video for you or we'll get into a Zoom session together. Let's go over this. Again, I want to make sure that you guys are good with completing this square. So you're ready to move on to Integrated Math 3 next year. Exit question you guys can handle on your own. I think that should give you all the detailed guidance you need to be successful on this worksheet. Thank you for so many of you who are listening to these and have been doing a great job on your worksheets.